StaR. A star is a luminous sphere of plasma held together by its own gravity. The nearest star to Earth is the Sun. Other stars, mostly in the Milky Way, are visible from Earth during the night, appearing as a multitude of fixed luminous points in the sky due to their immense distance from Earth. Historically, the most prominent stars were grouped into constellations and asteriums, and the brightest stars gained proper names. Extensive catalogs of stars have been assembled by astronomers, which provide standardized star designations. For at least a portion of its life, a star shines due to thermonuclear fusion of hydrogen into helium in its core, releasing energy that traverses the star's interior and then radiates into outer space. Once the hydrogen in the core of a star is nearly exhausted, almost all naturally occurring elements heavier than helium are created by stellar nucleosynthesis during the star's lifetime, and for some stars, by supernova nucleosynthesis when it explodes. Near the end of its life, a star can also contain degenerate matter. Astronomers can determine the mass, age, metallicity, chemical composition, and many other properties of a star by observing its motion through space, luminosity, and spectrum respectively. The total mass of a star is the principal determinant of its evolution and eventual fate. Other characteristics of a star, including diameter and temperature, change over its life, while a star's environment affects its rotation and movement. A plot of the temperature of many stars against their luminosities, known as Hertzsprung-Russell diagram, allows the age and evolutionary state of a star to be determined. A star's life begins with the gravitational collapse of a gaseous nebula of material composed primarily of hydrogen, along with helium and trace amounts of heavier elements. Once the stellar core is sufficiently dense, hydrogen becomes steadily converted into helium through nuclear fusion, releasing energy in the process. The remainder of a star's interior carries energy away from the core through a combination of radiative and convective processes. The star's internal pressure prevents it from collapsing further under its own gravity. Once the hydrogen, I'm just reading here, I'm not sure if this is the truth. Once the hydrogen fuel at the core is exhausted, a star with at least 0.4 times the mass of the Sun expands to become a red giant, in some cases fusing heavier elements at the core or in shells around the core. The star then evolves into a degenerate form, recycling a portion of its matter into the interstellar environment, where it will contribute to the formation of a new generation of stars with a higher proportion of heavy elements. Meanwhile, the core becomes a stellar remnant, a white dwarf, a neutron star, or if it is sufficiently massive, a black hole. Binary and multi-star systems consist of two or more stars that are gravitationally bound and generally move around each other in stable orbits. When two such stars have a relatively close orbit, the gravitational interaction can have a significant impact on their evolution. Stars can form part of much larger gravitationally bound structure, such as a star cluster or a galaxy. Read about designations, units of measurement, formation, evolution, protostar formation, main sequence, post-main sequence, massive stars collapse, distribution, characteristics by age, chemical composition, diameter, kinematics, magnetic field, mass, rotation, temperature, radiation, luminosity, magnitude, classification, variable star structure, nuclear fusion reaction pathways. Read all about StaR. StaR. StaR.